right, and we're live. What's going on, YouTube? It's time for another day of Advent of Code. Today we're tackling day 12, and we'll dive in here very shortly. Interested to see what we have for us today. See what kind of problem we have. Hopefully we can solve it in a reasonable amount of time. Looking forward to diving in and seeing. I haven't seen I don't think we've seen a parent-child node problem in a while, or yet. So I'm thinking maybe we might have some sort of tree problem coming up. Feels kind of appropriate to see one of those. We'll see. I'm excited to dive in and see what we might be getting into here. I'm also looking forward to honing my skills a little bit further and just kind of seeing how we can improve day to day. I may end up doing a review. Yesterday I got tripped up a little bit because they said that the stones would come out in order, but actually the order wasn't important to the final problem, which led me down a 45-minute journey of inefficiency. So hopefully I take a little bit more time today and think through the problem. I'm going to get my iPad out ready. Think through the problem a little bit further before I start putting in code together, and maybe we can do it the right way the first time this time. Yeah. Minute 54. Hey, what's going on? Glad you joined. Just getting ready to start Advent of Code day 12. We got a minute and 30 left. Does anybody have any predictions on what the problem might be for today? Whether we're going to be tackling a grid problem or some sort of string regex, or maybe a node problem, a tree problem, parent-child relationships. Any thoughts? I was thinking about day 12 from last year. Was a node problem where we had to traverse paths starting at start, which was the root node, and ending at end distinct paths along the way. There are big caves and small caves. So wonder if we'll do something similar to that today, or maybe we'll get into something else. Got 19 seconds. All right, let's get into day 12, garden groups. Why not search for the chief historian near the garden and his massive farm? There's plenty of food, so that the historian grabs something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example, this 4x4 arrangement includes garden plots growing 5 different types of plants, A, B, C, D, E, in each group into their own region. In order to actually calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4. The type E plant are in a region of area 3, and type D plant are in a region of 1. Okay, got it. Each garden plot is a square, and so it has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with a perimeter 10. Okay. The type B and E plants are each in a region with perimeter 8. And the lone D plot forms its own region with perimeter 4. Hold on. Each garden has 4 sides. The perimeter of a region is the number of sides of garden plots in the region. Okay, so 1, 2, 3, 4, plus the top is 8. 2 sides is 10. Okay, got it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 for B. Okay, got it. Visually indicating the sides of plots in each region that contribute to the perimeter using, okay, yep, got it. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. Regions can appear in other regions, okay. So this is what this X is. Multiple separate regions, got it. One containing all of the O garden plots, and the other, the 4 X regions each have area 1 and perimeter 4. Region containing 21 type 0 plants is more complicated, in addition to its outer edge contributing a perimeter of 20. Its boundary with each X region contributes an additional 4 to its perimeter for a total perimeter of 36. Due to modern business practices, the price of fence required for a region is found by multiplying the region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has a price of 4 times 10, which is 40. Okay, we'll deal with the pricing in a little bit. The second example, the region with all the O plants has price 21, etc. Here's a large example. It contains a region of R, a region of I, another region of I, okay, a region of M, a region of S. So it has a total price of 1930. What is the total price of fencing of all regions on your map? Okay, let me just look at the puzzle input real quick. Well, that's fun. It almost looks like a picture. Okay. Okay. Got it. Okay. So this is what I think we can do. My thoughts are, if we start at 0, 0 and we crawl out in the 4 directions, and we try to build a region based on the 4 directions. Let me look here for a second. I don't know if we have to worry about angles. I don't think so. Let me look here if we can see what that type of plant is indicated by a single letter, which is growing at the same type of plant that are touching horizontally or vertically. So we only have to worry about up, down, left, and right. So we start here at position R, and we grow out for each letter that matches. And if once we find a letter that doesn't match, we stop processing and we process all these, and then we keep a map of visited locations. Once we're done with that, we go to the next iteration, next, so on until we get to an unvisited location. We build that region. go to the next one, we build out that region and we mark all the visited ones as we go. And then eventually we get down to a set of all of our visiteds, and then we loop back through all of our visited sets and we determine if what the value is. I think that should be fine. We're really just looping through this once, and then for each one we're being selective about which records we check next to build our region and plot, and then we continue through until we find one that hasn't been processed, and we'll have to look through every single one of these records once to do that. I think that's going to be okay, so that's the approach I'm going to take. And we know that our test input is 1930. So we'll come back here, we'll change this to 1930. And then as far as our reading of our data, we're just looking at strings here. So we're going to come back here and we'll use our and we'll save that, and that should give us all of our records. And we'll worry about the scoring of each one separately because we have the two perimeters, but let's loop through this. And then we can say for right, so we know we've got that. And thanks, Matthew. I actually have my GitLab repo if you are interested. I try to take a test-driven approach to this since we know what the end result is supposed to be. But you're more than welcome to pull it down yourself and use it, or pull from it, or, you know, it's up to you. I'm just going to call this step. And I need a visited list. We'll just make it a map of string. And so we'll do this is an int, this is a string, and this will be yeah, it's good practice to go through these. I haven't, you know, I've done some of admin code over the last couple of years, but it's fun to tackle these problems and kind of see what we can get, you know, what we can produce. This is row, and then this should be visited key row column, and we'll do, yeah, we could do an empty struct there if we really wanted to make the value smaller, but not going to worry so much about that. And so we're going to pass our grid in here, and we're going to pass in our character, and we're going to pass in our map, a string to bool. and because we are going to step, and then we want our direction. So we can say for we're going to step, and we're going to pass our matrix in. We're going to pass our V in. We're going to pass our direction in. And we're going to pass our visited in. What this doesn't do is return back our the things that matter, right? So I think that's the last thing we need to do is return back a set of ints. Yeah. So first thing we're going to say is if m dot, well, okay, we're not going to use v here. We're going to do a position instead. Yeah. So we'll do r comma c, and we have a direction. So we'll say if m dot plus equal dir sub 0 and c plus equal dir sub 1. And we'll say if m dot in bounds r comma c, and we'll say if not, then we return that. So we know we're off the map, and we should do nr because I want to maintain the original for our next check. And we'll call this nc. This will be fine. nr and then c. And then we can say if nr equal to, if m sub r sub c we'll say not equal, then we return. So these are kind of like the guard clauses. And then finally, if we are good, then we can say essentially what this is, which means we can step and we want to do nr, nc, and then all of the directions. So anytime we step somewhere, we want to go there again. And then one more caveat is that if we've already visited, so if it's not in bounds, if the values aren't equal, and if we've already visited, we return the empty set. And then we can otherwise set visited equal true. Me? No, I don't know any assembly. I've looked at some, but I've not done anything professional or in detail with assembly. Is there a particular project you have in mind that you'd like to look into further? I wouldn't mind giving it a look. I mean, so we're going to set the visited to true so we don't come back to this particular node. And then, so one last thing I want to do. So we need to, for lack of a better name, so this should then set ret to this each time, and then ret is always going to append whatever the sub piece is. So we should get our grouping of letters that match. So then this is going to be our groups. And yeah, so this is going to be that. So we're going to append the entire group so that we have all of the index positions in each group so we can come back and analyze. But I think we're going to start there. We'll go with that. So now if we and something like that. Something like that. First try? Nope. Score. Yeah. Okay. Yeah, we can get rid of that for now. All right. You know, it's late and I've been doing this pretty much nonstop. I'm making all kinds of mistakes. There we go. Okay. Lots of empty slices. That did not have quite what I was expecting. Let's just log the first group. That way it's a little bit clearer on what's going on here. Right, okay. just a whole bunch of those. Yeah, so they should never be nil. This is NR, NC. This has to be NR and NC. Okay, that might be part of my problem here. Yeah, there we go. Okay. But there is still one issue, which is here. I need to do two things. First is maybe I can reduce this, but I'm going to just go ahead and do this for now and keep it in here. So we're going to keep one at this higher level. So as we go through that whole loop, we're going to check. And if we've already visited, we're not going to visit again. Otherwise, we visit it for the first time. And we're going to do our new group. Okay, so there is a little bit of an issue here and then this is going to be new group equal to append new group ... and then we do groups equal to append groups new group. Probably just call this group. Let's make our variable names a little bit better. So we've got 11. Let's just count this real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, perfect. So I think we got the right groups. And then if we look, our first group is, that's actually our second group. Let's change our logging real quick. We'll log the 0 index group just so we don't go crazy. And we've got 1, 0, 1, 1. Why did we get 1, 0 as our 0th group? We're missing that. Oh, that is because this should be R comma C. Here and here. So we start the group off with the index that we're on at that level, which is 0, 0. And there we go. So, and then 2, 4 is the last one there. So 0, 1, 2, and then was there a 3, 2? There's a 3, 2. Okay, perfect. So okay, so the region of R plants with price is 12 times 18, which is 216. So now we've got our groupings. So let's look at R here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is the area, right? So like the area, if we look back here at area, in order to calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. So now if we come through here and we say, okay, for we can say our area and then we've got the, so this is going to be a little bit more challenging. So how would we do this? Is there a way to calculate an area of points? Is this just like a normal area? So we've got 1, 2. Yeah, okay. So is it something like, we did like what's the calculation here? There's gotta be like just a way to do it with math. Yeah. Is there some way to just like, we know that the top here, 1, 2, 3, 4. Just trying to think here if there's a way where we can determine this. I mean, if I go through each grouping and I check each point, if to calculate, I could start at the first point and I can check all the directions. And if there is a character of the same, then we don't count it. But if there's either out of bounds or a character of a different, we count it. And then, so we would basically be recalculating every grouping. Considering the size of the graph that we have right now, I don't think that's going to be that terrible. Maybe we just try that and kind of see where we land. And so and we'll go with our matrix again. Yeah. And then from here, we've got a grouping, and so we can say for yeah, so we can say if in bounds p sub 0 plus dir sub 0, and then we'll say p sub 1 plus dir sub 1 say if not, then we'll do perm and then continue, and then we're going to return perm, and we'll put it in here. Okay, so now that's good. If we know that we're out of bounds, we know that we're on the edge, and we'll calculate both of those for a given thing. Otherwise, if we can just say or yeah, I'll just do this because this will be easier to articulate. Actually, we'll just call R because we don't have another one. So if our current position is not equal to RC, so if either of these conditions are true, so if we're not in bounds or the letter doesn't match, then we're going to increment, and that's going to be our perimeter. So now it will be, we'll call it perm okay. So much for that keyword shortcut. Our M, and then we pass in our group, and then our sum or our score is plus equal area times perm. And then why is it not like this? Our score equal to 0.0 maybe. And then we return score. Yeah, let's try that out for our test here. Awesome. So now we'll grab our input for the 7th time apparently. Place that here and see if it will run in a reasonable amount of time. It wasn't confusing. All right. Awesome. Part 1 done. Let's take a look at part 2. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Consider this example again. The region contains type A plant has 4 sides, as does each of the region contains plants of type B, D, and E. However, the more complex region containing the plants of C has 8 sides. Using this new method of calculating the per region price by multiplying the region's area by its number of sides, region A through E have price, etc. Okay. I don't understand. So using a perimeter to calculate the price, you need to use the number of sides. So C has 8. What is considered a side? Did it tell us here? Perimeter using and the sides of the plots in each region that contribute to the perimeter using. Okay, so why does C have 8? Why does C have 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. I don't understand this. A has 4 sides. 1, 2, 3, 4. Oh, okay, I see. And then C has 1, 2, 3, 4, 5, 6, 7, 8. Okay, I understand now. So that's kind of fun. All right, well, let's see if we think this through a little bit. If I start here and I check to my left, I know that I can get a side row. If it's not similar to what we're doing parameter, I can check to my top and I know I can get a top row. And then I can iterate to the next one. That's also a third. So 1, 2, 3, right? We go down to the next C. We go over to the left. We already have that column cataloged as a side. So we're not going to record it again. But if we try to go down, that's not us. That's a row now. Then we go over here. Okay, so very similar, but instead of recording the R and the C, I'm just going to record the rows and the columns, if you will, that we're in, and that'll give us our sides per a thing. And if we're out of bounds, that will be a so if I go to the right, that is a column, and if I go vertical, it's a column. If we go horizontal, that's a row. And so we'll catalog. Okay, right. So then let's do sides. So let's come back here. Let's create a part 2. We could probably condense this down later, but for now it'll just be easy enough to copy and paste. And then instead of doing perimeter, we're going to do sides, and we're going to create a func called sides. We'll borrow from our perimeter one. It's a very similar pattern. So we'll copy it. Yeah. A little bit more complex, but not too much more. So what we need is, I mean, we could just do, I mean, this will work. Int and bool. and calls. So this will give us our ability to, anytime we reach a condition, instead of just blindly adding it, we're going to add to this, and we're going to say, I don't know why I did a continue here, but we'll do rows yeah, we'll break this into two. So what we can do is, and we'll do slice of int, and we'll do matrix.dir up, dir down, and then that. And then we're going to do the same thing here. But the difference is, and the reason we're doing it twice is because instead of doing all four directions, we're going to catalog slightly differently. So, and this is going to be dir left and dir right. So now if we're going up and down, we know that we want to catalog our rows. So this would be rows. Oh, this is Golang. And then we can just do the length of rows plus the length of calls. And that should be it. We don't actually have to count this anymore. And our same test input produces 1206. So we'll go back to our test. We'll put in a 1206 here. And we will rerun our test. And we've got 1930 for part 2. Expected 1206, actual 1930. Ah, that would be why. All right, 1002. So what didn't I do right here? Let's see. Yeah, let's just put some logging out real quick. So what I can do is have you Doc Jolis, have you coded in Golang before, or like what language are you most familiar with? And let's just go ahead and do our group. Gotcha. So area 12, sides 10. Okay, so I got that one right. Area 4, sides 4, that one's right. 14, area sides 22. So why didn't I get C right? So C nice. Glad to hear that. I'm pretty close. I'm not particularly fast at these. I'm just kind of enjoying the process of going through them. Um, and I figured I'd document it here. So our C's are wrong. What else do we have here? 14, 16, 14, 28. So our area's right. We know that, but the sides are off. So 16. Why did we not get 16? 1, 2, 3, 4. Let me go back here and see. Matrix, dir up, dir down, left and dir right. So we're going to do both. Oh, did I have these? Do I have these reversed? If I go up, I want that column. And if I go left, I want the row. I think I have these reversed. Okay. Well, 12 and 9, 4 and 4, 14, 13. Okay, maybe not. If I go to the left, no, I do want the row. Go to the left, I want the row. If I go to the right, I also want the row. Still gonna be the same result. Yeah, so if I go, if I'm here, and I go to the right, which is J, I want this. I want to catalog that. And if I know there's an edge here, then we're going to track that. Let's look at the side a little bit more. Maybe I'm missing something in the calculation for the side. The E-shaped region has an area of 17, has 12 sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Hold on. 12 sides Y. 2, 3, 4, 5. Let's go back to our simple example. A is 4. 1, 2, 3, 4. Oh, wait a second. Has 4 sides. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Each straight section of fence. So, but, I mean, shouldn't this actually be 8? I mean, I don't make the rules here, but 2, 3, 4, 5, 6, 7, 8. I just don't understand what it's asking for here. Each straight section of fence counts as a side, regardless of how long it is. Do we... 1... Oh, let's look at B for a second. As do each of the sectors B, D, and E. So 1, 2, 3, 4. A has it because it's 1, 2, 3, and 4. Right? Okay. So that makes sense. C of 8 makes sense, but why would my algorithm not work? So go to sleep, Siri. This is rows. This is calls. Yeah. 12 and 10, 4 and 4, 14, 16. Still getting this one wrong here. So let's look at this 14, 22 for the C's. So I need to go to the larger example. Draw this out. Okay, so the problem is this gapping right here. So it's not, the way I'm calculating it is wrong because I'm just assuming that it's the row, which allows me to capture this, but because there is other C's in that row that are at different positions column wise. That's why it doesn't work. Okay. So I know what the problem is. Now, how do I correct for that? Oh, really? That was interesting. Okay. So we need to can I look at this from a different perspective? If I'm here and I go here, no. Yeah, I had a CPU spike. I don't know why. It should be getting better. Let me see. Yeah, OBS is having some issues here. Let me try closing some things. See if that might help. That's what I get for a string on a MacBook Air. Let's see here. It still says poor. Well, let me focus. Okay. I appreciate that. So what if I took a different approach here? And instead got all of the positions outside. Yeah, it's an M2. It's an M2. It actually it's done pretty well. This is the first time that I saw that it's had issues. So I've streamed a couple of times. Well, actually, this is my 12th live stream video, actually, to be more precise. So maybe I have too much going on here. Okay, sorry, let me focus. So I'd like to finish this up here. So if yeah, I'm not sure. So my CPU is spiking like crazy. I think maybe I just had something going on. Not sure. So if I traverse this, I think I'm close. But it's the continuous side part, right? That is an issue, where we've got this side here, and then there's this break, and then like it's not contiguous is the thing. So I think I have to be a little bit smarter about, it's not just the row and column. I have to walk. So if I'm at a point and I can check all the surrounding points, and if one of them is a point, I can check. So if we go down and there's that is considered a side because there's not another C, then I can check the left and the right. And if there's one to my left, then I can utilize that and consider that as part of a side and follow that chain. But if I'm heading left, so like here, if I'm heading left, So I had the direction, I had a direction, and I continue to follow that direction. And when that is broken, that is considered a side. And that's cataloged, and then that's visited. And then I can check the other point for the other side and the other point for the other side. And I can continue in that direction of left. And then I guess my visited would have to be the point and the side in which we are visiting on. I'm not sure if that sounds crazy or not. But I think that's what we have to do here. I think so. So this isn't going to work. So we know that's not it. And so if we come here, we visit, we're going to go I think this is how we want to do it. Maybe I can come up with a better function name. Great if I hit the right key. But for a given direction, so the visited here is going to be this, saying that we visited this node in full. But we're also going to have if but we don't want just this. We're going to do a func.sprintf, and we're going to do the key, and we'll do the direction. So yeah, there we go. So we're going to check to see if we've visited a specific direction, or if we found an edge at a specific direction, and if we have, we're not going to calculate that one again. Maybe follow edge, question mark. And so if we go up and we find that we're not inbound, or that position is not equal, so then we're going to want our R and C and our direction. And really what we want to do here is we just want to follow the edge in either direction. And all we're going to do is, if this is true, then we want to set visited for that specific edge. So and then we want to recursively call visited. So we want to recursively call follow edge. So we are right. And then we call M visited R, C, and then dir. So the dir for the follow edge is not, so if we're on R and C, we want to go left to right. And we want to go right. And we want to do that on P0 and P1 because we want to go right to left of that. But we also need a check dir which will be that. So essentially, if we were to look at this, at least this is my plan. go black here. And then we go 72 maybe, do 64. And then if we change the font, something a little bit more Monaco, sure. And maybe we zoom out just a little bit, and then I will bring up my tablet. Well, I gotta change the font on my tablet because for some reason it's not the same. I don't know why that is, but that is what it is. Venlo, let's try that. Go with bold, why not? Okay, so the idea is that I'm going to start at some position. We'll say, we'll start at position C, and we're going to check all of these surrounding areas. And anytime I find that we are on an edge because that area is either out of the bounds, I'm going to, so like if we look at this one here, that is out. So we know we have an edge here. I'm going to proceed to the next C, or the next one to the right, and the next one to the left. And I'm going to determine if this is a part of that same edge in that direction. And if it is, I'm going to catalog that in the map and for that given direction. And so then that should give me the ability of, you know, if we go back to, we maybe use this other side here, starting here, and I check the left side and I see that there is no edge, then I will go down to the next C, because that is in the horizontal fashion, and I will check and I will see that it's part of that same edge, and then I will go down to the next one, and in this case that's not a part of this edge because there's another C here, and so that one does not count as being part of that edge. So that stops the calculation on that edge. Then I'll go to the next point, or the next direction, which is up. And I see that we have another edge here. So this is a new edge because it's a new direction. And I will check the next C and see that it's a part of that same direction on that same plane. And then we'll go to that next character and know that does not get included. And then that C at that edge has been processed already, so we count that. And then we just kind of go around and we keep doing that until every edge is fully processed, and I think we'll get to an end. So at least that's the plan, that's the strategy. So we follow the edge, and really if all following the edge is going to do is going to mark visited on the appropriate character. So we set visited to true for a given direction. That's great. I don't know why it's an arrow here, but okay. Maybe because of this. Yeah, not sure. Okay, so right. So we don't want R and C. We checked R and C, and then we're going to mark visited true, and then we're going to follow the edge until we get to an end. So when we follow the edge, we are so R is equal to So this is our original R and C, and this is our check R and check C. So if in bounds check R, check C, and if M of so let me actually do so the first thing is M sub R sub C. If that doesn't equal our M sub new R new C, then we continue. So that's basically saying that it's not the, or we return. So that's saying that if it's not the same character going left or going right, then we want to return. And then if it is the same character, then what we want to do is we want, this is actually NR and NC, so that's that new character. And if the check, which is going to be the direction, so it's going to be above or below, depending on what direction we were heading. So we're going to go to the left, go to the right, check above or check below, depending on what iteration we're on. And we're going to see if that is true, then the NR and the NC is going to be at the check, not the direction we're heading, but the check in this case, that's the check. And so we are going to indicate that is true. And then since this is also true, we're going to follow the edge again, passing in visited. So if we're not in bounds, or it's not the letter we're currently on, we're on an edge, right? And then we also want to say if not m dot inbounds nr nc, then we return. So that way, if we ever get off all the way to the left or all the way to the right, all the way up, all the way down, we just return. And then we continue to follow the edge, and it's going to be nr nc, and the direction is going to continue to be the same dir, and the check is going to be considered the same check. So we're going to recursively follow that until we return. So as long as that we have something out of bounds and we're following along the edge, we're going to follow that edge. And so that is going to give us that. And so how do we turn that into an edge or a score or side? So I think then what that just means is that each time we iterate and we get to this point, it is just incrementing. And so we've got to do the same thing for this, but now we have to inverse left, dir up, and I'm sorry, dir right. And then this is dir up and dir down. So I think if we do that, that'll ensure that we don't double visit anything. Okay, and then this should be just sides at this point. Awesome. So same input. I think we just run day 12 now. Awesome. There we go. That's the right answer. We got a gold star. Way to go. Let's clean some stuff up real quick. Let's just kind of walk through this. I think that worked out pretty well. Our strategy, at least that we walked through here, worked out the first time at least efficiently enough. It's some seconds, so I'm not, not too worried about it. I mean, I'm sure there might be some way to optimize here, and we can look at that in a second. Just clean up some of the logging here. Yeah. So let's kind of review. Let's look at part one. So part one, we just need to go through and create all the groups. Thanks, man. Appreciate it. So just kind of in group one, we walked through using a map, using a visited node for the specific row and column, marking all the keys or all the locations in a unique map. And then anywhere we would step to all of the surrounding locations. I think we could actually reduce this into just a, well, maybe not, but we step through all the surrounding locations. And if they're the same character, we continue to recursively step. So we could look at that here. We have a couple of guard clauses. So if we're not in bounds, if it's not the same character, or if we've already visited previously, any of those conditions, we exit. Otherwise, we set visited true because we're visiting that node for the first time, and we step through all the directions kind of recursively. The thing that's kind of neat about this is that since we do that, that means that each iteration we go through here of each value, since we visited it in the subgrouping, we'll just skip a whole bunch until we get to the next, fresh group and then work through that. So I think that's pretty efficient. And then lastly, we just go through and calculate the area, which is the length of the group, and then the perimeter, and then set the score to that, adding up. Perimeter was pretty straightforward. We just walked through and kind of calculated all of the inbounds in that same kind of directional thing. And then finally, to round it off, we had to, for part two is very similar, but we had to determine the sides as opposed to the perimeter. And so the way that I chose to do that was to kind of follow the edge. So we start by finding a point in the grid or the grouping, and then we visit that point, and then we go through a set of directions. And then if we find an edge for a single point, we follow the edge in either direction, just marking everything that is on that edge. And so that gave us the ability of, in a condition where we had a turn or a change of a side, that we were able to catalog that, but we could still catalog all the flat sides. So once I implemented that correctly, we were good to go. Problem solved. I think I could probably reduce some of this repeat code here. I might do that off stream here and do some refactoring, but I think this was pretty successful. So I appreciate you guys hanging out. Do you have any questions, Dark, Joel, about Go, or anybody? If you have any questions or just about anything at all, I can feel willing to answer those, or we can just hang out for a bit. No? All right. Well, I appreciate everybody hanging out. It was great, great having everybody, and